Hey guys, in today's session we are discussing algebraic functions from a different perspective, functions and relations.
Okay, so in this session, we are looking at functions and relations. So we are still under the section of algebraic functions, and in this session, we are looking at something that is a bit different because we wanna understand the relationship between the x values and the y values of different graphs, and then from there we can decide whether those graphs are functions or not. So let's get started. Okay, so let's look at this guy. So we can see that we have a straight line. Okay, so y is equal to x plus 2. We can see that the slope is a positive slope, or it's a positive gradient. We can see that we have y is equal to 2 as our y-intercept, okay? And we spoke about sketching a straight line when we were talking about straight lines in our previous session, whereby we said that in order for us to sketch a straight line, we only need 2 points, the y-intercept and the x-intercept. And from this, our equation, we can see that the y-intercept is 0 and 2. Okay, and then the x-intercept, to get the x-intercept, you make y to be equal to 0. So this is what you do. The 2 will go to the other side and then it will become -2. So x is equal to -2 is our x-intercept. So our other point will be -2 and 0. Okay, so those are the 2 points that we need to sketch. And then from there, we can just plot the points and then we will join the 2 points so to get our straight line. Okay, so that is essentially what we did to plot this graph that we see over here. Okay. Okay. So let's see what is going on over here. So let's look at the different x values. So let's start with this guy. If we look at this guy, he has one y value. Okay. There's one y value that is associated with that guy. And then if we look at this one, well, but okay, it's not straight. If we go upwards, we see that okay, there is only one y value, and then this one as well, one y value. Okay, that one y value. Okay, and then the same thing can be demonstrated if you go to the other side, because this one is one y value, that guy is one y value, and then this one as well, it's one y value. Okay, so what we are trying to see, or what we see, is that each x value, each x value has one y value. Okay, that is one thing that we see. Okay, and another way of looking at this is that we can say that each y value has its own x value. In other words, there is no sharing of x value. Each y value has their own x value. Okay, so that is the definition of a function. Okay, so a function is a situation, a relationship whereby each y value has their own x value, or they have their unique x value. So, in other words, in order for a graph to become a function, there must be no sharing of x values, okay, between the y values, of course. So let's write our findings. So our findings are saying that for this graph, we see that every y value has a unique x value, has a unique x value. Now, because of this situation, this guy, this graph, this straight line graph, is a function. What is a function? A function is a graph whereby each y value has a unique x value. So what we don't want to happen is we don't want two y values to have the same x value. Now, if that happens, then we know that graph is not a function. Okay. Very importantly, a function is not another word of, or it's not another name for a graph. So when we're talking about functions, it's not some fancy name to describe a graph. So a function is a specific type of graph. Okay. So we see that, and then we can analyze the situation further. Now, we can see that for every y value, there's a unique x value. Okay. So that qualifies this graph to be called the function. Okay, but then let's look at the x values. The x values, they only have one y values as well. So in this situation, or we call this situation a to one one-to-one relationship. So the relationship between the x values and the y values of this straight line graph is a one-to-one relationship. And this is a function. Okay, so if it's a function, my handwriting, Jesus Christ, one, one to one. Okay, let me move this one. Okay, so this is the one-to-one function. It's a function. Okay, so it qualifies to be called a function. So this is the first relationship, and then let's look at this guy now. Okay, so this guy is a parabola or a quadratic function. So you remember that when we are sketching quadratic functions, what we only need 3 points. Number one, we need a turning point, which is basically the p and the q value. The x value is the p, and then the q value is the y value. Okay, and then we need the intercepts as well. So the x-intercepts, very simple. We make y0, and then we solve that equation to get the x values. And then another very important thing is for us to determine the shape. Before we can start sketching a quadratic function, we need to know how it will look. Okay, that is why we spend so much time going through the specifications or the features of a parabolic function so that we can sketch and interpret any question associated with those functions. So that is how we sketch this guy. Okay, we are not there. We are trying to understand the relationship between the x and the y values. Okay, let's do that. Let's look at this x value. Okay, and that x value. Okay, so there are different x values. You will agree. One is -1, the other one is +1. So they are very different. They are not the same. But then if you look at the y values that the the y value that they are associated with, or the y value at those x values, you see that the y values are the same, because for this point, for this one, for this x, the y value is 0. For that one, the y value is 0 as well. Okay, and then so this is the y, and these are the two x's. Okay, so let's look at another set of x's. This guy and that one. Okay, so this one will come here, that one will come there, and then we can see that the y values are still the same. Okay, the y values are still the same, and we can do this for any two points that are on either side of the y-axis. We can see that because of how the graph is, two x values will share the same y value. Okay, hopefully that is clear. Okay, now the question becomes, okay, then is this graph a function or not? Is it a function or not a function? Remember, our definition for a function states that a function is any relationship whereby there is no sharing of x values. Okay, so there's no sharing of x values. If there's no sharing of x values, then that relationship is a function, or that situation is a function. Let's check for that and see whether it's the case or not. Let's see. Um, this y, y of 0, it's one y and it has two x values, and that is not a problem because we don't mind sharing y values as long as we don't share x values. Okay. If you go to this y, you see that we have one y and we have two x values, and that is not our problem, or that is not a problem because we are allowed to share y values. Okay, we are allowed to share y values. The only thing that we cannot share for a function is x values. So because in this situation we have one y value and then we have two x values, that one and that one. Okay, the same can be said about any 2 points in this graph. So we see that this is indeed a function because every y value has a unique x value. So in other words, there are no two y values that have the same x value. Because of that, this graph is a function. Okay, this graph is a function. This one is a function, and then a function. It's a function. Okay, and then now let's see what type of function it is. Okay, so this one is a one-to-one function. Okay, and then this one, let's see what type of function it is. Okay, so we see that we have, you can see that, my technology is playing games today. Okay, so we can see that we have two x values. Okay, let me just use this. We have two x values, this value and that value, but then they have the same y value. Okay, the same thing is true. Yeah, we have two different x values, that one and that one, but then they both have the same y value. Okay, and we have been seeing this. So this is a trend in this particular graph. So the relationship that we have here is what we call a many many to one relationship. Many to one relationship. So in other words, many x values are associated with one y value. Okay, so many x values to one y value. So we call this a many to one function, a many to one relationship. Okay, so this is the situation with this guy, and we have established that it is a function. Okay, and then let's look at the last one. Um, this one is x squared plus y squared is equal to 1. So this is an example of a circle. So this is an equation of a circle. We call this a unit circle. Called the unit circle because the radius of this circle is equal to 1. Okay, so we call this a unit circle. Now, here we have a different scenario. Okay, let's consider that this x value over here and that x value over there. Let's say this guy is negative a half, and then this one is positive half, positive 1 over 2. And then let's see, for this one we have two y values, that one and that one. Okay, and then for that one we have two y values as well, that one and that one. Okay, so now what we can see in this particular graph or in this situation is that we have one. Okay, let me just do this so that it will be clear. So the y value is that one, and the y value over there is there. Cool. So we have a situation whereby we have one x value, but then we have one, two y values. Okay, so these two y values are sharing one x value. Okay, and that is not what a function is, because remember, we are not allowed to share x values. So in this particular situation, we already know that this is not a function because we have two y values that are sharing the same x value. Okay, and this can be demonstrated on this side as well, because we can see that this x value, this one, this one of positive a half has y value there, and it has another different y value over there. So we can see that this single x value is being shared by two y values, and that is out of the definition of a function. So we know that number one, this guy, it is not a function, not a function. Okay. And then another point to make is the fact that now we wanna know the relationship, whether it's one to one, many to one, and so forth and so forth. Okay. Now, by looking at this situation, you can see that each x value has many y values. So basically, we can see that the relationship here is one to many. Okay, one to many. So one x value is associated with many y values. So the relationship is one to many. This guy is the x, and then that one is the y. So it's one to many. Okay, so that is the relationship. Now we know from here, we know that if the relationship is one to many, then it's not a function. Okay, it's not a function. All right, so those are the three scenarios that we were planning on looking at. But then let's say maybe we are in an exam situation, and then they want us to decide whether a graph is a function or not. Now, how do we do that? Okay, so there's something that is called the vertical line test. So basically, what you do is you you take a vertical line. A vertical line is just a straight line. You take a vertical line and you run it through your graph, right? You run it through your graph, and if that vertical line intersects or meets the graph once at each point, then that graph is a function. Okay, let me just demonstrate what I'm talking about. Let's see if I have a ruler over here. Yes, I do. Okay, so let me just use the ruler. All right. Okay, I want it to be vertical. Vertical, 90 degrees. 90 degrees, 90 degrees. Mm, mm, okay, 90. Okay, here we go. So what I'm saying is, in order for us to determine if a graph is a function or not, we use our ruler, and then this is called the vertical line set, by the way, whereby we take our ruler, we pass through the graph like this. Now you can see that at every instant, every instance whereby this vertical line or this ruler is touching the graph, it touched the graph once or at one point, because at this instant there it's only touching the graph there. Okay, and then that one, this instance, it's only touching the graph there, and then and so on and so forth and so forth. So if the graph passes the vertical line test, that graph is a function. Okay, so this is the easiest way of determining if whether a graph is a function or not. Very practical and very quick. So the vertical line test. Okay, so we know that this straight line is a function. Okay, we decided that already. And then let's see with this parabola. Okay, so we do the vertical line test. Basically what you do is we move the ruler, or we move the vertical line past the graph. Okay, so at this point you see that the vertical line is meeting the graph at one point, which is at this point, that one. Okay, and then if we move our vertical line to this side, the same thing is happening there, everywhere on the graph. So this serves as a confirmation that this is indeed a function. Okay, this is the function. And then let's go to the last one. Here we will see, we could see why is this one not a function. So let's show that using the vertical line test. Okay, so at this point the graph is not touching the vertical line at one point, because at this point it is touching it, at that point, this point, and at this point it is touching it as well. So it is me, this guy, this graph is touching the vertical line twice on one occasion. So this is not allowed. Okay, because this is not allowed, this is not a function. Okay, and at this point as well, it's true. You could see the graph is touching the vertical line at 2 points in one instant. Okay, and that is not a function. Okay, the same can be seen there, so forth and so forth. Okay, so that is one way of checking if the graph that you have is a function or not, by performing what we call a. Okay, so today we are looking at inverse functions. So what is an inverse function? So let's consider a graph. Y is x plus 2. Okay, we did sketch this graph in the previous session, so let's just do it quickly. Nope. Okay, so let's give it another try. Yay. Okay, okay, and then we can 8. Okay, that straight line like that, and then another one that. Nope, let's do it like that. Okay, so you know that that's y, and then that is x. Okay, so when we sketch, we know that we need 2 points, the y-intercept, which will be there, and then the x-intercept, which will be over here. Okay, so this is x is minus 2, and then this is y is 2. So this is our graph. Okay. Our graph, our graph. Okay. Another line that we must be familiar with is this line. Yeah, no, okay. Is the line that passes the origin of the Cartesian plane. Uh, uh, my technology is playing games today. Let's see. Mm, ah, let's try it for the last time. Let's see. Let's give it another shot. Much better. Okay, so there's this line that passes the origin of our Cartesian plane. Now, the equation for this line is y is equal to x. So it's a straight line. It has an equation of y is equal to x. Now, this is the function. Okay, this is the function, the straight line. Okay, and we saw in our previous session that this guy is a one-to-one function. We explained all of that in the previous session. So if I take this guy, this function that we have, and I flip him, I take this guy and I flip him to the other side, what will I get? I would get a straight line that is something like this. Okay, I'll get a straight line which is something like that. Now, that straight line that I obtain, or that graph that I get, is what we call an inverse function. So an inverse function is the graph that you get when you take the function and you reflect the function over the line y is equal to x. Okay, so that's the case. Okay, so that is the geometric way of thinking about this thing of a inverse function. But then now, what if we want to like do it in a formal manner? How do we move from a graph to an inverse function or to an inverse graph? Now, that one is very simple. We simply look at the points that we have on that graph, and then look at the points that we have in that graph. We have this point, which is -2 and 0. And then we have that point, which is 0 and 2. Now, these points belongs to the function. Okay, let's see. We could see how we're going to move from here to an inverse function. Okay, so this one will be for the inverse function. Basically, what we do, we swap the coordinates. Okay, so this point will be 0 and -2, and then this guy will be 2 and 0, and that will be it. So these 2 points are the points that we can use to plot the function of the inverse, or the inverse function. Okay, so that is the case. Okay, so we see that this point is actually x is equal to 2 and y is 0. We see that that point, this one, is actually x is 0 and y is -2 from there and there. Okay, so basically, this point is that point, is this one. It's this one, and when it comes this side, it is flipped, or it is swapped. The coordinate swaps, and then it becomes that one. Okay, this point becomes that point, and so forth and so forth. But then the main idea is that an inverse function is a function that we get if we take the graph of the function and we throw it over the line y is equal to x. Whatever that we get on the other side of that line is the inverse function, or the inverse graph. Okay, so that's the idea behind this thing of inverse functions. Okay, now what if they want me to determine the equation of an inverse function? So if I'm given the equation of the function and then they want me to determine the equation of the inverse function, very simple as well. Okay, let's do that. The equation of the function that they gave us is y is x plus 2, right? So to determine the equation of the inverse function, Number one, we have to swap the the variables. So the x will become the y will become the x. So to get the equation of an inverse function, what do we need to do? Number one, we need to swap x and y, swap x and y, swap x and y. And number two, we need to make y the subject of the formula. And then after that, we know that that particular equation is the equation of the inverse function. So number one, we swap x and y, and then number two, we make y the subject, of the equation, the subject. Okay. So let's put that into practice. So for this example that we have, we will make we will swap first. So it will be x is equal to y plus 3 plus 2, I mean, and then we will make y the subject of our formula. So we will take 2 to the other side. So we'll have x minus 2 is y. Okay, so we can write it like this: y is x minus 2, right? So this guy is the equation of the inverse function of that guy, of this one. Okay, so in other words, this equation is the equation for that graph. Okay, y is equal to x minus 2. And we can tell from the graph as well that we have the y-intercept at -2, the x-intercept at x is equal to 2, and so forth and so forth. Okay, so this is the situation. Okay, that is how we determine the equation of the inverse function if we are given the equation of the function. Okay, now very important, the theme that has been coming up over and over again is that in order for us to change from this thing, from a function to an inverse to the inverse function, we just need to swap the x and the y's around, right? So that can be extended. We can say that the because of that swap, the domain of the function will become the range of the inverse, and the range of the function will become the domain of the inverse because of the swapping around. Okay, so we can say that one thing that we see is that the range of an inverse function, okay, of an inverse function is the domain let me just write it like this: the range of the function. Okay, let me just phrase it like this: the range of the function becomes the domain of the inverse. Okay, becomes the domain of the inverse function. Okay, and the reverse is true. That's the domain of the function. Domain of the function becomes the range of the inverse. Range of the inverse function. Okay, that.
We've come to the end of our session. Please like and share our videos with your classmates, friends, and family members. Ensure that you follow us on all socials at XYZ Math Tutoring, and don't forget to subscribe to our YouTube channel. I have dropped the link to our YouTube channel on the comment section. Go check it out. Have a great day.